So we are talking of motion on an incline. When you've got an object on an incline, firstly you've got the angle of the incline, theta. Okay, the angle of the incline. Now, since this is an object that is on an incline, obviously it's going to have mass. That's an object, right? Anything that has got that occupies space has got mass. Obviously, we know that. So, because of the mass, is going to have weight, and always goes 90 degrees. Like not really 90 degrees, but it always goes down, like down. Okay, so that thing is going down like that. That's the weight. This is the weight force. And how do you find weight of this object? Weight is given by mass times gravity. So this is the mass, the weight of this object, mass times gravity. Now every object that stands always has a normal force. If an object is here, the normal force will be up. If an object, if you put like you more like put something on a wall like that, the normal force is going to come out. It always make 90 degrees to the surface. If you have got something like this, you put it on top, the normal force is going to come down. It always make 90 degrees to the surface. That's normal force. It doesn't dip. It's not like constant. The way you have weight force which always goes down. The normal force always goes 90 degrees away from the object. Okay, so we are going to have the normal force also here, like that, making 90 degrees to the surface of the object. So that is normal force. Now if I get to make an extension of this normal force, I make an extension of the normal force. I extend it like that. Okay, the angle that we are going to form here is going to be equal to the angle of the incline. It is also going to be theta. Then from there I'm going to join these the weight force and this other side that you found. I'm going to join them like this, making 90 degrees. Okay, I should be able to make a 90 degrees. So this angle that I've made here is a 90. So what I've seen, this side is going to be parallel to this side. They'll always be parallel. They are always parallel, right? So I'm going to take this. This I'll take it as the x-axis. Up, I'll take it as the y-axis. Now, firstly, I'm going to start with this sign. Okay, let me, since I've taken this as, so I'm going to say this is x. I'm going to say this is y, since we've not labeled those two portions. So this thing we are able to see here, that is the hypotenuse, and the hypotenuse of this right angle triangle is mass times gravity, right? Now we know that the sine of an angle theta, so what we are looking at is this triangle, the sine of an angle theta is going to be given by opposite. We can see that opposite to the angle, that is x, over hypotenuse to the angle, that is mass times gravity. So this is going to give us, if we make x sub to the formula, it is going to be mass times gravity sin theta. So what I've done is just multiplied this by that. So since this side, as we said, is parallel to this side, by virtue of anything being on an incline, there's always a force that pulls things down an incline because of their weight. That is called force due to gravity, or force due to the weight of an object. So Fg, since they are parallel to x, then Fg and x, they are equal. That is going to be mg sin theta. Okay, like that. From here we can also talk about cos using our SOHCAHTOA, that cos theta is going to be given by adjacent over hypotenuse. Now the adjacent side, you can see that is y. The hypotenuse is mg, right? So we can make y substitute the formula. Y is going to be mg cos theta. Now if we look at the net force in the y direction on this object, remember y direction is like this. So we first consider the force going up minus the force coming down, that is y, right? Now since this object is not moving up or down, like it's not jumping out of the incline, the net force, it doesn't have any acceleration up or down, the net force is going to be 0, because net force is mass times acceleration, and that is going to be normal force minus y. But where there is y, we're going to substitute mg cos theta. Now I can make the normal force subject the formula. Going to see that normal force, I'll take the mg sine theta cos theta the other side. Normal force on an incline is going to be given by mg cos theta, right? Normal force is mg cos theta. Are we good? We are good?
Yes, good.
Great. All right. Now, let's say this mass which is on an incline, let me just get to remove it. I put a new diagram and then we're going to be working with that. So just take note of these equations I've written here. Normal force mg cos theta, fg is that. And then we see now how we are able to work with some things. So again, here is the incline. Okay, the 90 degrees there. Let's say we've got an object at this point. Now, let's say this object is moving up. You are pushing it. There is a certain force. You have applied the force pushing this object up. Pushing this object up. What will be the acceleration of this object? Now, we're going to look at the net force in the x direction. Net force is going to be what is the force pushing it in the direction of motion. So this object is going forward. Okay, that's the direction of motion because that's where you are pushing it. So net force is going to be the force going in the direction of motion minus what is, do you have any force going down? Like, do you have any force going in the opposite direction? Do you have any force going in the opposite direction? Anyone? Okay, by reason of this object being on an incline, it means there is a force of gravity pulling it down. Okay, there is Fg. By reason of it being on an incline, so there's going to be Fg in the down direction. So it is going to be applied force minus Fg, right? Now, how do you find net force? Net force is given by mass multiplied by acceleration, and that is going to be equal to applied force minus Fg. What is Fg? Fg is given by mg. Can you finish? Fg is given by mg what? Friends, you're just reading, like just reading. Let's speak something. These things should start sticking in
It's
our
sine
minds.
theta, sir.
All right.
Mg sine theta.
Mg sine theta. Just say something. Like they'll get to stick. Okay, now we want the acceleration. So the acceleration of this system is going to be given by applied force minus mg sine theta divided by the mass. This is the formula that gives us the acceleration of this object on an incline. So let's say the applied force, we got to apply 20 newtons and this object has a mass of 10 kg. Okay, and the angle with the incline is 30 degrees. Okay, they have said find the acceleration of the object up the incline. Acceleration is going to be equal to applied force, which is 20, minus mass, which is 10, times gravity, which is 9.8, and then times sine the angle of the incline, which is 30 degrees, divided by, okay, divided by the mass. The mass is what? The mass is 10. So this is going to give us what? 20 minus, we know sine 30 is a half, so half can go into 5, that is into 10, that is going to give us 5, and 5 times 9.8, please can someone get to do for us the math? 5 times 9.8, right? That is going to give us a 49, and then minus, I mean divided by 10, so the acceleration is going to be 20 minus 49. Okay, 20 minus 49, and then divided by 10, that is going to be negative 2.9 meters per second squared. So this is going to be the acceleration. Now if you look, we are taking the direction of motion as going up, but you found a negative acceleration. The meaning of this is that this object will not be able to go up. Instead, it is going to be sliding, going down. Like this force that you are applying is not big enough to push the object up. So instead, it is going to be accelerating downwards. That's why you found this negative acceleration. So the direction of motion is going to be down. Alright, so the force is too small to push the object up. Instead, it's going to be accelerating down. So if they've told you it was coming from rest, find the final velocity. They've told you it was coming from rest, find the final velocity. And then if it covered a distance, say up the incline of 5 meters, okay? Covered a distance of 5 meters coming from rest, find the final velocity. You know that v squared is equal to u squared plus 2as. So this is going to give you v squared being equal to initial is 0 plus 2 acceleration is what? The acceleration is negative 2.9. Okay, the distance covered is 5. Now, since this object is going to be moving in the opposite direction, okay, it's going to be moving in the opposite direction. I'm going to also take this distance as negative. Why? Because it's going, like, consider this is a Cartesian plane. This is the positive x-axis, this is the positive y-axis. So if something is going in this direction, it's going towards the negative y direction. I mean negative x direction. So that's why I've attached a negative on the distance, because otherwise you'll not find the square root of a negative number. Okay, so to find v is going to be the square root of 2 multiplied by 2.9 multiplied by 5. So this is how fast it's going to be moving, going down. 5.39 meters per second. That will be the velocity of this object going down. Okay. Now, before I proceed, any question? Any question? Any question? All right. I'm just hoping we are understanding instead of just being quiet. Now, this operation that we have done here is we've taken that the mass is moving on a frictionless, like there's no friction on an incline. Frictionless, that is a formula. Now, what I want you to understand is not a formula. Like, I don't use the formula when I'm calculating. What you should understand is how to get things, okay? How to get things. So what of if the incline has friction? Since in the previous one we looked at a frictionless incline. What of if there is a friction? Maybe you've been told that the coefficient of kinetic friction between the object and the incline is maybe 0 point something. Okay. What of if there is friction? What gets to happen? Just a minute. Just a minute. All right. Can we proceed? Are we following? Can I continue?
Yes, you can continue.
All right. So if there is, all right, if there is a friction on this incline, and then you are pushing this object, let's say you are pulling it with a force going up like that. Okay, you have got a certain applied force. Now, because there is friction, the friction is going to be going in the opposite direction, and that obviously is kinetic friction. By reason of this being on an incline, there is also another force that is pushing this object downwards. What kind of force is that? What force? Hello? What force is going to be going downwards?
The matter.
Ha, you people. Okay, that is Fg, right? Because of this being on an incline. So if you are finding the net force on this object, net force, okay, on this object in the x direction is going to be applied force, the forward force, that is the force pushing this thing in the direction of motion, minus any force going in the opposite direction. Now we have got F K, kinetic friction in the opposite direction. We also have Fg. So they're all going to carry a negative sign. Now net force is given by mass multiplied by the acceleration. That is going to be equal to force minus kinetic friction. Okay, kinetic friction is given by coefficient of kinetic friction times normal force. Right? Fg we determine is given by mg cos theta. And this gives us mass multiplied by acceleration being given by force minus mu k times normal force. Now normal force on an incline like this is given by mg sin theta. Okay, so don't put mg there. It's not mg but mg sin theta. This is an incline. And then minus mg cos theta. So therefore the acceleration is going to be applied force minus mu k mg sine theta minus mg cos theta, divide everything divided by the mass of the object. Now let's say this applied force was 500 newtons, this mass is 10 kg, okay, and then the coefficient of kinetic friction between the box and the the incline, let's say 0.2. We want to find the acceleration going upwards. Okay, we want to find the acceleration going upwards. So the acceleration therefore is going to be given by applied force, which is 500 newtons minus mu k. Make sure that mass is always in kg. This is not chemistry where you use mass in grams. Okay, mu k, that is 0.2, and then mass is 10, gravity 9.8, and then sine. Okay, let's say the incline is at 20 degrees, sine of 20 degrees. Now please don't be confused. If they've not given you the angle but they've given you the height, let's say for example they've said the height is 2.1 and then the distance on the incline, like they've given you the distance on the incline, they've said maybe it's 4. Now they've not given you the angle. You should be able to know that if they've not given you the angle, like you've got something like this. Okay, this is theta. They've given you this maybe as 4 and then this is 2. You have got the opposite and the hypotenuse. You know that sine theta is given by what? Opposite, which is 2, over hypotenuse, which is 4. Okay, so that means you can find theta. Theta is going to be what? Take the sine the other side. That will be sine inverse. 2 over 4, that is just 1 over 2. So in this case, then theta would have been 30 degrees. Okay, so we can find the angle even if they've not given you, but they've given you something. So just take note of that. But here we are using 20 degrees, not 30. So it will be minus mass again, that is 10, right? And then g, that is 9.8. And then cosine, the angle, that is again 20 degrees. Everything over 10, which is the mass. So let's determine the acceleration. Please, if you've got a calculator, you can go on and punch with me. That is 500 minus 0.2 times 10, that is basically a 2, multiplied by 9.8, that would be 19.6, and then sine 20. Okay, and then minus 10 multiplied by 9.8 multiplied by cos 20. That has given me about 401.205, and then divided by 10. Okay, that is going to give us 40.12 meters per second squared. For this one, you can say the acceleration is positive, meaning that it is going to be going up. So now let's say this object came from here, like it started from the bottom here, from rest. Okay, from rest, and then it went up the incline, which is 4 meters up. It went up a 4-meter incline. You want now to determine the final velocity when it reaches the very end. How do you do that? v squared is equal to u squared plus 2as. So v squared is equal to, it's coming from rest 0 plus 2. Acceleration, we've determined 40.12. The distance, let's say the incline is 4 meters, like from the bottom here to the very end, there is 4 meters. So again, in this case, if they've not given you, let's say they've not given you the distance of the incline, but all you know is the angle of the incline and the height. Let's say the height is 2.1. How can you find the distance? You know that sine the angle is 20 is given by opposite, which is the height, okay? 2.1 divided by hypotenuse, which is the distance. Meaning that for me to find distance is going to be 2.1 divided by sine of 20, right? So you can punch that. 2.1 divided by sine 20. That is going to be about 6.14. That is the distance, then 6.14. So to find v, we are going to just square root. So the same 6.14, I'm going to multiply it by a 2, also multiply it by a 40.12. And then the answer that I get, I'm going to square root that. So that the final velocity is going to be about 22.196 meters per seconds. So this is going to be it, right? Are we good? Are we good? Any question? Yes, Musonda.
Can you please go through how you find the distance?
Okay, the distance, if you've been given the height, if you've been given the height, okay, let me put an incline there. You have got the angle of the incline. This is the distance. Okay, that's the distance. And then you have got here as the height. You have got the height there. You want to find the distance. You know that sine theta is given by opposite. In this case, the opposite is the height over the hypotenuse, which is the distance. So I'll cross multiply, meaning that height is going to be equal to distance multiplied by sine theta. So if I want a distance, now to avoid confusion, let me use d. Okay, I'm going to use d. Meaning that height is this in theta. So to have distance, it's going to be height over sin theta. If we want, we can even know the equations. We are good?
Yes.
Right. Now, if you've got an object on an incline, but there's no force that is applied to this object will just start itself going down. Okay? Like if you don't apply any force, like they've just told you there's an object that is on top of an incline, right? Let's say uh, the incline here is 4 meters long. The angle of the incline, let's say, is 30 degrees. And then you have got a 20 kg object which is on top of the incline. Like it is not pushed. Now I want to find the final velocity when it reaches the bottom. The final velocity when it reaches the bottom. Okay? The question is, how do you find it? So we're going to again look at the forces which are acting on this object. So the net force in the x direction on this object. So you need to consider if an object you're not pushing it, where will be the direction of motion? So you need to know that it will just be sliding down, like it will just be moving down. Okay, so that is the only force that is going to be pushing this object down, which is what? The Fg, right? So net force is going to be mass times acceleration, and we know that Fg is mg cos theta. So the mass and the mass cancels, meaning that an object that is on an incline and is sliding doesn't depend on the mass. So whether you are a 50 kg person, 100 kg person, when you go on an incline and you get to slide, you are going to reach the bottom at the same time because you're going to be accelerating at the same time, as long as you've the initial velocity which is the same, meaning that the acceleration is going to be given by g, which is 9.8 cos theta. The angle is 30 degrees. So we can determine the acceleration. So that is 9.8 cos 30. And the acceleration is going to be 8.487 meters per second squared. So to find the final velocity, since it is coming from rest, final velocity is going to be equal to initial velocity, which is 0 plus 2, acceleration, which is 8.487, then times distance. The distance covered, that is 4 meters, right? So to find the velocity, quite easy, just say 2 times the 8.487, then times the 4. Answer that you get, square root. So velocity is going to be about 8.24 meters per second at the bottom. Right? Are we good? Are we good?
Yes.
All right. Now let's say this incline has got friction. Let's say this incline has got friction. What happens? Okay. Let's say the coefficient of kinetic friction here is 0.2. What is going to happen? So if there is friction on this object, let's look at the net force in the x direction. The net force in the x direction is going to be equal to the force that will be making this object to move, because there's no force that you are pushing, is going to be Fg. Okay, so be sliding. That is Fg. Now, because there's friction on this object, because there's friction, so this object is supposed to slide down going like this. So kinetic friction is going to act as an opposition, right? It's going to act as an opposition. Now, Fg and kinetic friction, they support each other going down when you have got an object that you are pushing up, because by reason of this object being on an incline is going to be pushed down by Fg, and kinetic friction is there. It doesn't know, like, it's something that is not definite. Everywhere where the wind is blowing, that is where they get to 10. So kinetic friction, if motion is in this direction, like you are pushing something in this direction, kinetic friction acts in the other direction. Now in a case like this one, you have got Fg, that is the one which is causing the object to move. So kinetic friction will be acting in the opposite direction to oppose that movement, right? And we know net force is given by mass times acceleration. That will be equal to Fg, we know is given by mg cos theta. Kinetic friction is given by coefficient of kinetic friction times normal force. But normal force on an incline, mg sin theta. So we have got masses at every point. So the masses are going to cancel out. So the acceleration therefore is going to be g, which is 9.8, okay, cos theta. Now I can actually just first factorize out a g because it's common, to be g open brackets cos theta minus mu k sin theta. So that will become the formula. So the acceleration is going to be g 9.8 cos the angle theta is 30 minus mu k 0.2 sin the angle 30. So let's see what we get there. So I'll start with what is inside, that is cos 30 minus 0.2 sin 30. It is about 0.766, and then the answer that I get, I multiply by 9.8. So the acceleration is going to be about 7.51 meters per second squared. Remember, this acceleration is going down, right? That is how we get to work out this. Next time, we'll look at something that is like this. Okay, let's say you've got an object here like this, and then you put something like there. You put an object on an incline, you tie it to another object which is here. Okay, how fast will they be accelerating? And also look at something like this. You put an object here, and then let's say you tie it to an other object which is there. How fast are they going to be moving? Thank you so much for today.